Greetings and welcome to the session which is being hosted by the South African Mathematics Foundation, which administers various mathematics competitions, one of which is the team competition in South Africa. Today, we are going to discuss the solutions of one of these competitions, which was set in 2025. The team competitions have two parts to it. One is the individual, and the other is a team of 10, where they try to solve the problems together as a group. But today we are going to do the individual paper, 2025 Junior. In other words, the grades 8 and 9. All right, without any further ado, let's go straight to the problems which we will discuss. Okay, so let's look at the very first problem. All right, question 1. So this question says the odd number as 2025 digits, 2025 digits. So there are 2025 digits in this number here. The A and B are single digit numbers. So this is the first digit and B is the last digit. And all the digits between A and B alternate, as you can see, between 3 and 7, both included. All right. If this number is divisible by 15, okay, so in other words, this number is a multiple of 15, which means it's a multiple of 5 as well as 3. Excuse me. So if it's a multiple of 5, then B is 0 or 5. Okay, because that's the last digit. And it's also a multiple of 3. Sum of the digits is a multiple of 3. Whenever a number is divisible by 3, it means that when you add all the digits, it's going to be either 3 or 6 or 9 or something like that. Okay? It's a multiple of 3. So we need to add all these digits to see what the sum is. The 2000, so let us add. Okay. So you've got the A, I don't know what it is. B, I don't know what it is. But I can see I got 3, 7, 3, 7, 3, 7. And there's a 3 at the end. Let's add all the 3 sevens. How many 37s are there. Well, you have to ignore the first, the last, and that one to count all the 37s. So there are three things you ignore. So you've got 2025 numbers altogether. You have to remove 3 from there. And that will give you the number of 37s, but you have to divide that by 2 because 37 consists of 2 digits. So this, if you work it out, you get 1011. So there are 1011 such numbers. And we're adding the digits. 3 plus 7 is 10. So add. So you got A, and you've got 1011 tens. Because you got 3 plus 7, 3 plus 7, 3 plus 7. Then you're stopping here. This last 37. You still have a 3, and you have a B, and this is a multiple of 3. All right, you want this, the sum of the digits is a multiple of 3. Now you want plus, this number here is already a multiple of 3. So this is a multiple of 3, and this is also a multiple of 3. 3 times 1. So therefore, A plus B. We use the symbol 3 as a factor of. This vertical sign is a factor. So 3 is a factor of A plus B. A and B are single digits. So therefore, A plus B can be 3 or 6 or 9 or 12 or 15 or 18. The largest value it can have is 18 because A and B could be 9. Now, you want the largest value of A plus B. Okay, you might be tempted to say it is 18. But one has to be a little bit careful because we know that B is either 0 or 5. So if you want the largest sum, A plus B, okay, you'll have to make B equal to 5. If B is 0, that wouldn't give you the largest sum, obviously. So this implies that B is equal to 5. So if B is equal to 5, then what is A plus B? A plus B will be, B is 5, so this is out. You can't have 5 plus A equal to 3, so that is out. And even this is out here because if B is 5, then this will make A to be 10, and this will make A to be 13. 5 plus 13, 5 plus 10. And B is a single digit number. Right? So there are only 3 possibilities. A plus B, it could be 6, 9, or 12. So therefore, you want the largest value. Therefore, the answer is 12. A plus B. The largest possible value for A plus B is 12. Right, I don't know why this pen is not, the writing is not very clear. Let me try to get this a little bit better. Now, I always provide the answer as well, typewritten answer, largely so that you can, in case you missed a few things while I was talking, always have something there available. And let's have a look at what answer I had. So you see the answer is 12. 7 plus 5. Okay, let's get to the next question. Question 2. There are 100 people in a room, and 60 of them claim to be good in mathematics. Okay, but only 50 are actually good at mathematics. Okay, if the 30 people in the room admit that they are weak in mathematics, so if they admit they are weak, then they are weak. Okay. And one half of those who did not answer are good in mathematics. Now, how many people didn't answer? You had 50 people, 60 of them answered, and 30 people admitted. So you have 90 people who said that they are either good or weak in mathematics. There were 90 of them. So the number of people who didn't answer the number of people who did not answer is 10. And half of them are good in mathematics. 5 of them are good. Now, why am I focusing on that? Because the question says, how many people in the room are good in mathematics? So you got, of those people who didn't answer, there were 5 of them. And those who were answered, there were 50 of them were good, according to this. So therefore, you got 50 plus 5. Nothing is said about the people who said that they are weak, right? So you'll have to accept that all of them are genuinely weak. So there's nobody good in mathematics in that lot. So the answer is 55. Oh, I see. Now I can understand why this thing is, the writing is so thick here. Okay. Now, so we have solved this problem. Let's just check to see whether the answer that I got earlier on was 55. Oh, there it is. It's 55. So 55 is the answer. Okay, let's go into the next question, which is question 3. Question 3 is, if m cubed is equal to 3, what is 81 over m in terms of m? So we can write this in terms of m. M cubed is equal to 3. Let's try to simplify this 81 over m. Now I've got this color right. Now 81 is 3 to the power of 4. So we'd like to write both of them as powers of 3. M cubed is 3. So that means that m is the cube root of 3. The cube root of 3 is written as 3 to the power of 1 over 3. So I don't know whether you have done exponents, but this is 3 to the 1 over 3, or 3 to the 1 over 5, or whatever, is the third root, or the cube root of 3, or the fifth root of 3. So at the bottom, I can put 3 to the power of 1/3. So I'm going to assume that you have done exponents. So you got the same base, and then you have to subtract the exponents 4 minus 1/3, and that gives you 4 is 12 over 3 minus 1 over 3. So that's 11 over 3. Oh, okay. Now, they say in terms of m, so m is 3 to the 1/3. So this is 3 to the 1/3. That's your m. But it's all raised to the power of 11. So I'm isolating 3 to the 1/3. 11 over 3 is 11 times 1/3. So the third law of indices creeps in. And so this is m to the power of 11. So that's a question. Write this value in terms of m. And the answer is m to the power of 11. Okay. So let's just check to see whether that is the answer that I got before I came here. Right, there it is. M to the power of 11. Let's get on to the next problem. It's question 4. Question 4 says 2025 over n squared is an integer, which is saying that n squared is a factor of 2025. So they say how many possible integer values of n exists. All right, so n squared is a factor of, like I can see 2 plus 2 plus 5 is 9, and 9 is a square. So n squared could be 9, right? In which case n is 3. But the integer values, in other words, you're allowed to include negative numbers as well. So if n squared is equal to 9, n could be 3 or minus 3. So you're allowed to include minus 3. So there are at least 2 possible solutions. By inspection, you can see n is going to be, and 3 or 5 works. The same with 25. You can see 25 goes exactly into this thing. And so n squared could be 25, because if you divide 25 by 25, you're going to get an integer. 25 goes exactly into it. So you got n squared, n could be either 5 or minus 5. So already you've got 4 possible values for n. So the question is, how many are there altogether? All right, so we have to factorize 2025. This is 25 times 81. How do I get 81? I take 20 times 4, because each 100 has got 4 25s in it. So 20 times 4 is 20 is 80, and there's one more 25, the 125. So 80 plus 1. Okay, and this is 80. 81 is 3 to the power of 4. It's 9 squared times 5 squared. So this is the factorization of 2025. And now I know that we don't know what n is, so let n be equal to, the prime factors of n will have to be the same as the prime factors of that, because n squared goes exactly into that. So let n be equal to 3 to the power of a times 5 to the power of b, right? So n is going to have that, n has got no other factors, because it will have the same factors, prime factors, as 2025. So therefore n squared will be 3 to the power of 2a times 5 to the power of 2b. Square this, you're going to get 3 to the a times 3 to the a, which is 3 to the 2a. So let's rewrite this 2025 now in its factorized form. So here you got 3 to the power of 4, 5 squared And here you've got 3 to the power of 2a and 5 to the power of 2b. Okay, I see that this particular paper asking a lot of questions on indices. Okay. Um, yeah. So the problem is now, what is A and B? What are the values of A and B? Because we need to find out what are the values of n, right? So we can solve it if you know what A and B are. Now, if you look at this, you're going to get 3 to the power of 4 minus 2a. You subtract indices, and this is 5 to the power of 2 minus 2b. Okay, so 4 minus 2a must be an integer. See, 4 minus 2a is equal to, could be 0, 3 to the 0 is 1, or 1, or 2, and so on. But notice that 4 minus 2a must be a positive number, because otherwise this wouldn't be an integer. It could be 0, so 4 minus 2a, let's look at it that way. It's greater or equal to 0, which means that a is less than or equal to 2. 4 is greater than 2a, 2a is less than 4, and a is an integer, so a is 0, 1, or 2. So there are only 3 possibilities for a. All right. Now likewise, there's 2 minus 2b. Let's just keep that in mind, because we're trying to solve for a and b, you see. So 2 minus 2b is also greater or equal to 0. And there you will have that b is less than or equal to 1. So you have that b is 0 or 1. Okay, so there are 3 possible values for a, and there are 2 possible values for b, which means that for each choice of a, you've got 2 choices of b, and there are 3 choices for a, so therefore there are 6 possible pairs, a and b. Right? Let's just write them down. I'm going to write it down like this. AB is a pair. Okay, it could be. I've underlined those. I could have, if A is 0, let's take that A is 0. B could be 0 or 1. I finished with that. If A is 1, B could be 0 or 1. If A is 2, B could be 0 or 1. 2, 1. Right. And in each case now, we remember n is equal to 3 to the power of A times 5 to the power of B. So if you see what n is 3 to the 0 times 5 to the 0, and that is 1 times 1. So n is that. And here you have n is 5. And here you have n is 3. And you have 3 times 5, 15. And here you have 3 squared. And here you have 3 squared times 5, which is 45. Okay, so what is it? So these are the values for n. So n squared is what? So you'll see that n squared is equal to Let me just create some space here. So these are possible values for n. So n squared. I'm allowed to put negatives, you see. So that's why I just want to go into n squared. N squared is 1 or 25 or 9 or 15 times 15 is 225. 9 times 9 is 81. 45 times 45. So all these are now factors of this, right? Because this is an integer. So now I can write down n is equal to plus or minus 1. Oh, by the way, I did find 9 and 25 earlier on. If you remember, I put plus or minus 3, plus or minus 5, and I found 4, but now they're actually 12 here. It's plus or minus 1, plus or minus 5, plus or minus 3, plus or minus 15, plus or minus 9. See, these we didn't guess. So when you do the mathematics, it gives you all the possible values for n. So there are 12. They ask how many integer values there are, because 6 times 2 is 12. So the answer is 12. Okay. Let's just check to see whether we had got the same answer when I did this thing at some other time. Okay, there are 12 values for n. You can see it's here somewhere. 12 values for n. All right. So let's proceed with the next problem, which is number question 5. Close your eyes and roll 2 dice. Okay, what they are saying here is that you're not supposed to be looking at the dice. Now, the teacher announces that at least one of the dice shows a 6. So you're rolling 2 dice, and one of them is a 6. You don't know what the other one is. So what is the probability that both dice show a 6? Okay, so you got 2 dice, remember there are 2 different dice. They're not the same dice. Like for instance, 6 and 1 is not the same as 1 and 6. So what are the possibilities? Having rolled these. So the possibilities are okay, you could have 6-1, 6-2, 6-3. One of them is a 6, 6-6. If the first dice is 6, but bear in mind that the other dice could be 6. So there you will have 1-6 or 2-6 or 3-6 or 4-6 or 5-6. I've already counted 6-6. But you want to know what is the probability that both dice show 6. So there's only one case here, obviously, where they both show 6. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 possibilities. And only one of them is a winner. Both show 6. So therefore the probability the required probability is 1 in 11. That's only one of them is a success, and you got 11 possibilities altogether. Okay, so that's how you do that problem. And if you just check to see whether this is the answer that we got, yes. So we got the same answer, 1 in 11. Okay, so let's get to the next question, which is question 6. Question 6 says, in the equation 8 times 7, and they got this other symbol here, plus, whatever that symbol means, is equal to 31. Variables A and B are natural numbers less than or equal to 10. So A and B are digits, in other words. No, it could be 10. So 10 is not a digit. So A could be anything from 0, or it can't be 0. Natural numbers start from 1. Remember that. So it could be 1, 2, 3, up to 10. So those are the possibilities for A and B. So remember that. But this funny looking symbol can be any one of the 4 operations, plus, minus, multiplication, or division. And what is the sum of all possible values of A plus B? All right, let's see now. A times 7 is 7A. And this plus could be any one of 4 possibilities. I'm going to put it down like this: plus, minus, times, divided by B is equal to 31. Okay, let's take them one at a time. You've got 7A plus B is equal to 31. So so 7A is equal to 31 minus B. Okay, so this is a multiple of 7. So what are the multiples of 7? A could be a natural number, any natural number, from 1 to 10. Now this is positive. Right? So A is greater or equal to 1. So this is greater or equal to 7. All right, this is positive. So therefore the B is less than or equal to 37. 31 at least. Okay, but mainly you want to know what are the multiples of 7 here. Right. 7A is either 7 or 14 or 21 or 28. 7A could be 28. So if it's 28, then B is 3. But if you go beyond that, then you're gonna get a negative B, right? And therefore A is 1, 2, 3, or 4. Right? And for those values, A equals 1, B is equal to R. So that's a problem. Right. A is 1, then B is 31 minus 7, which is 24. And I think if A is 2, B is 17. Okay, you can calculate all these things. But B is a less than or equal to 10. So that is what I was getting a little bit confused about. I forgot that. So this is allowed. B is less than or equal to 10. So B equals 10 or 3. B is 10 or 3. So then that is for 7A plus B. So for the very first calculation, you got AB is equal to, A is 1, yeah, those first two are eliminated. A is 3 and B is 10. Or you have A is 4 and B is 3. 4 7 is 28 plus 3. It took such a long time. I'm sure there's a very much shorter way of doing this. You have to just see what are the multiples of 7 here, which are less than 31. You can get the answer. Okay, now that is for the plus sign. So I'll finish with this. Must now look at the minus sign. And there you got 7A minus B is equal to 31. So what are the possible values? So there you have 7A is equal to 31 plus B. And this is greater or equal. So now B is any number from 1 to 10. So therefore, B can be any number from 1 to 10. So therefore, B lies between, the smallest value for this is 32, and the largest value is 41. Before I didn't observe this. So now you're looking for the multiples. Not this is 31 plus B. Sorry. So 31 plus B. So therefore you got 7. In this case here you got 7A. Sorry, I'm really doing this thing badly. Let's just take all these things out. So you have, let's do all this all over again. So you've got 7A is equal to B plus 31, and B plus 31, the lowest value it can have is 32, and the highest value it can have is 31 plus 10. And what are the multiples of 7 between 32 and 41? There's only one. A must be equal to 5. 35 is the only multiple. And then in that case, if A is equal to 5, you have that B is equal to 35 minus 31, and that gives you 4. So you have that AB is equal to 5, 4. In this second situation, where A is minus sign. All right. Okay, so that's another possible value for A and B. Now let's take A divided by A times B is 7A times B is 31. So I finished two of these possibilities. I finished the minus. I go to the times now. So you have 7A times B, which is now 7A times B, is 31. 7AB is equal to 31. Now this is impossible. You see, A and B are natural numbers, so A times B is a natural number. right? So AB can't, 7 times no natural number, 37 is not a factor of 31. So there's no solution here. And the last one is 7A divided by B equals 31. And there you have 7A is equal to 31 times B, right? And now that means this is a multiple of 7, right? Which means that B is equal to, B will have to be 7, but then A is 31, right? So see, 7 is not a factor of 31. 31 has got no factors, but this is a multiple of 7 anyway. So therefore, you will have, the other way of looking at this is, I like this method. 7 of 31 is equal to B over A. Take equivalent fractions, because 31B equals 7A. Now, the only possibilities for this are, you have to keep multiplying this by 7 over 31, 14 over 62, 21 over 93. And you'll see that none of them have the solution where A and B are both less than 10. Right. So here also there are no solutions. So these are the only ones. So what is the sum of all the possible values of A plus B? So A plus B here is 13. A plus B is 13 here. And A plus B is 7 here. And A plus B is 9 here. So if you take all the possible sums of A plus B, all possible values of A plus B, you get 29. All right, so our answer is 29. Let's check to see whether that is indeed the answer. Oh, there it is. And so in case you didn't understand what I was saying, you can read this and try to get a better understanding of this problem. Okay, so we are now at this question here, question 7. Question 7 says the number in the figure inside a triangle indicates the perimeter. The perimeter is the sum of all the sides, the boundary, full length of the boundary. Okay, so the perimeter of a triangle is the sum of the 3 sides of the triangle. So the 19 represents the perimeter, for instance, here. That means when you add that plus that plus that, you get 19. Likewise, the sum of these 3, right? Let me just get a pointer out here. So the sum of that one, and this length is 18, or this length here, that length there, that length there. Oh, we don't have that. But we do have the sum of these 3 and so on. So now, knowing what the sums or what all these perimeters are, what is the perimeter of ABC? All right. Now, I just want to, let's try to simplify the problem and see what's going on here. By simplifying, what I mean is I draw, just take one triangle with another triangle inside it. And I have a triangle inside. And suppose I know the three perimeters. I'm not going to give any numbers. Suppose I know the perimeters, I say X, Y, Z, and W. So do I know the perimeter of the large triangle, the outside triangle? See, that's the question. You find the perimeter of the outside triangle. So the perimeter of outside triangle, large triangle, now watch, suppose I take the perimeter of this. I'm going to add that, that, and that. Right? And the perimeter of this is that, 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 and likewise, the perimeter of W is that, that, and that. Now we want only the outside, right? So the perimeter of the large triangle is, if I add this X plus W, X plus Z plus W, I have to take out these three here, you see. This is too much. I've got three more, X plus Z plus W, and I have to remove these three ticks, which is Y. So when you add these three numbers, you'll get 9 ticks altogether, but you only want 6 ticks because you got 2, 2, 2 there. And you have to remove 3 ticks. Which remove? The 3 ticks must you remove? It will be those, because those are not the perimeter of the large triangle. Okay, so there's a simple way of calculating the perimeter of the outside triangle. So like here in this case, if you look at this triangle here, that one, what's the perimeter here? So you work out the 3 corners minus the middle. So this will be 8 plus 4 plus 11. Those are the 3 corners, minus 9. All right, 11 minus 9 is 2, so you get 14. 8 plus 4 minus plus 2. So the perimeter of this triangle here is 14. So now I'm in the situation here. I know this perimeter, and therefore I know those 3. So therefore the perimeter of ABC again, you use the same principle here. It'll be 19 plus 17 plus 18. You add these 3 and you subtract the middle perimeter, which we just calculated to be 14. Right? So when you do it step by step, you can simplify this problem. And here, 18 minus 14 is 4, plus 27 is 21. So this is 40. So the answer to this problem is 40. Okay, so let's just check to see whether this is the answer that we got. Okay, you can see the last number there it is indeed 40. So let's get on to the next problem. So what is the next problem? The next problem states the following. You've got in the figure, a whole number is placed in each circle. So you're going to put whole numbers here. Could be 0. Whole numbers are 0, 1, 2, 3, and so on. Natural numbers start from 1, 1, 2, 3, and so on. Integers, everything in sight. -1, -2, -3, 0, 1, 2, 3. All the whole numbers and their negatives. Okay, so you got those numbers here are placed in such a way that the number in the upper circle equals the product the product of the two numbers in the circle immediately below it. What that means is that this number here is a product of those two. This number is a product of those two. That number is a product of those two. Okay, now the question is now, what is the largest number that can be put in the middle circle? What is the largest number that you can put here? Right? Okay, now to do this, I'm going to give symbols to this. Let's call it A, B, and C. Now I want to know what is the maximum value of B. That's the largest number. Okay, according to the rule, this number here is AB. It's a product of these two. This number is BC. It's a product of these two. And then you've got 360 is equal to the product of these two. AB times BC. And there is A, B squared, C. So you want to know what is the largest possible value for B. So it occurs as a square here. So let's look at 360 and factorize it. And you look for the largest possible square factor. And when you factorize the thing, you get 5 times 72. 72 is 8 times 9. So the largest square factor is a square number, by the way. When you factorize it into product of primes, the indices are all even. For it to be a square, the indices are even. Because when you take any number and you write it as a product of primes and you square it, then each of these indices is doubled. So if you got a square number, that indices will have to be even, because a double of any integer is an even number. So if you look at this now, you can see you can take out 2 squared and 3 squared. Right? Can't take out a square factor from this. So 2 squared, that's the largest you can go up to with an even power. And that is 6 squared. Right? So the largest value for B so this is your B squared, you see. So here you get A times 6 squared times C. Right, there's 36. So these two multiply to give you a 10. Right, and you can't extract any square factor from 10. So the largest value for maximum value of B is 6. Okay, and if you check it out, you can see what 6. If B is 6, then you can see A times C is 10, and you can put some numbers there, and you will be able to get to 360 eventually. Okay, so let's just check to see whether our answer that we had written earlier on. Oh, okay, so it's very similar to this. And you can see x is equal to 6. So the largest possible value, I called it x here, is going to be 6.